2, day 2. All right, today we're going to start off by finding area under the curve with the calculator. You just did it with the table yesterday. Now we're going to use the calculator to do it. So find.
Oh, so short notes today?
Should be.
Awesome. Thanks, Jim.
Area under the curve with the calculator. All right, so I'm going to give you the calculator where it's at, and then I'll tell you, we'll go through some examples on how to use it. So the function on the calculator that's going to give you the area under the curve is under distributions. So we're going to go to, I'll show you this after, just write it down. Distributions. Let me make sure here. And then we're going to look for normal CDF. And then what you are going to feed it is the left z-score of your shaded region, and then a comma, and then the right z-score of your shaded region. So if you give it the edges of your shaded region, it will give you the area in between. So this gives the area between two z-scores. So there's no 1 minus business, it's just use it the same way the whole time. So we'll do a couple of examples. So our first one is going to be the area to the left of a z-score equal to 1.43. Okay, and yesterday you did this, you just looked up 1.43, the number in the table was the area to the left. But on a calculator.
Mine says like lower, upper.
Yeah, we have a lot of
Yep,
weird stuff.
yep, but don't worry about it. I'm going to get there. 1.43, so this is 0. 1.43 is about here. And we're area to the left. Okay, so you guys said lower and upper. I said left and right. So
It
the
says lower, upper, mean. Is that what the?
yep, and standard deviation. Yep. Perfect. Okay, I'm going to show you both of them depending on which system you have. Let me get this turned on. Okay, distributions is right here above your vars key. It's in blue, so go there. And if you look, I'm going to go there. You've got normal PDF and normal CDF. We are using the CDF. This is the newer operating system. If you look on this one, here's the old operating system. Where's my calculator? Right here. Because I'm sure we've got both kinds working out there. Turn this on. Second, distributions, number 2. Okay, let me clear that out. Second, distribution, number 2. All right, so I told you you needed to feed it 2 things. The left z-score and the right z-score of your shaded region. This one says lower and upper. Lower meaning left, upper meaning right.
Wait, how come you have the normal CDF?
Because this is the old system.
No, in the one in your left hand, where it says.
Yep, normal CDF. That's the one we want to be on. Oh, I don't know why that's there. Clear that out.
Okay.
Matt hit something.
No, you
Blame Matt. Oh, I did that. Okay, so I know the right edge. This is my right z-score, 1.43. I don't want to go any farther to the right. How far to the left does my shading go? Forever. That's negative infinity. Okay, we don't have a negative infinity button, so we're going to approximate negative infinity by putting in negative 10 to the 10th. That's going to get us way, 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 way out there into the negative land. So, if you've got this kind, your lower is negative 10 raised to the 10th. Upper is my right boundary. I'm stopping at 1.43. I am on the standard normal curve. What's the mean on the standard normal? Because it's asking for the mean, 0. And standard deviation, 1.
Wait, I said 1. 1.4.
No, nope. The standard deviation is 1. We're at 1, 2, and 3. I just happen to be at 1.43.
Oh,
It's always going to be 0 and 1. How's that? These are always going to be 0 and 1.
okay.
Yep. So now on this one, all I've got to do is type in that negative 10 to the 10th, comma, 1.43. Done. And hit enter. I'll hit enter. This one I'll hit paste. Puts it in the line, hit enter. And there's the two answers. So the same answer. One this way, and they're both the same. Two different operating systems giving me the same answer. Sorry, I missed. Okay, which one's that one? Newer or older? The old one. Okay, so here you go, Matt. So you always have to give it two z-scores when you use NCDF. Left and right, lower, upper. So the area would be 0.9236. Just like the table gives out the areas to 4 places, we'll do the same thing here. All right. What if I've got find the area to the right of a z-score equal to 0.79.
Are you going to draw another graph?
Yes, I am. Because I want to see what's on the right and what's on the left. So if I shade this in, here's 0. A z-score of 0.79 is about here. Doesn't really matter, but that's 0.79. And I want the area out to the right of that. Okay. When I use NCDF, I need the two z-scores. How far out to the right is my shading going? Infinity. What do you think we're going to use to approximate infinity? Positive 10 to the 10th. So now you're going to use your NCDF. Go to your distributions, NCDF. Oh. What's my left z-score going to be here? 0.79. The left edge is right here, 0.79. I got to put that in first. Comma, what's the right edge of my shaded region? 10 to the 10th. So it's left to right. You're giving it the boundaries to find the area in between. Does that make sense?
Whoa, no. Yes.
Okay. So about 21% of the graph is shaded that way.
So you don't have to do any like 1 minus stuff?
No 1 minus stuff when you use the calculator. You're just going to give it the two z-scores. It will give it the area in between. So using the table, you had to do a little bit of thinking, and no, just know how the program works, and it's easy. So the area here, 0.2148. No 1 minus business here ever.
That's not bad at all.
Okay, now let's go between. You put in 10 to the 10th first.
Yeah. Oh.
This is my left edge, this is my right edge. So I got to put this first, this second. Left to right.
Okay.
Over here, my left was here, my right was here.
I got it now.
Okay. Put your hands on there if you have to. Left hand, right hand. Left hand, right hand. Now let's go between a z-score of negative 1.15 and a z-score of 0.5. Find that area. I'm going to make the graph. There's the 0. Negative 1.15 is about here. 0.5 is about here. And I want the area in between. So you use your NCDF, left to right, left edge to right edge. What's my left edge of the shaded region this time? Negative 1.15. And the right edge? 0.5. Negative 1.15, comma, 0.5. 0.5664. How about you guys?
Yep.
Okay, so NCDF is easy to use. You just have to feed it two z-scores. Now I'm going to ask you, if I give you an area, can you come back with a z-score?
No.
Calculator will do it if you ask it nicely.
You have to do the PDF?
Nope. All right. Or do I want to do that next? Let me see.
That's not good for today.
Oh, it is not good for the day. Did that. Oh, probabilities, and then we'll go. Oh. Yeah. When they say find the probability, you can change that word out for area, because area equals probability. So we're going to do that right now real quick. Area equals probability. They're the exact same thing. Probability. So example 2, find the probabilities. So I'm going to write it like the book will write it. Can you find the probability that the z-score is less than negative 2.86? So, probability and area are the same thing. What would be the area question here that I would ask that says the exact same thing as this? Yes. What's the area to the left of, because I'm going less than, negative 2.86? It's the same question. That doesn't make sense to you? Let me get rid of the word probability. Z less than negative 2.86. Can you shade that in on the graph? There's 0. Here's negative 2.86. And I want z to be less than that, so which way would I shade? Left. I'm looking for that area. NCDF will give me the area if I feed it two z-scores. What's my other z-score I need?
Negative 10 to the 10th.
Negative 10 to the 10th, because it's going that way. So to get this probability, I'm going to use that NCDF. Left edge to right edge. Left edge is negative 10 to the 10th. And right edge is negative 2.86. So area and probability, same question. You just have to be able to interpret this inequality into a shaded region. Anybody crank through that? 0021. Very small probability.
Can this just be?
Can this what?
Can this just like be the
Nope, not quite. We're almost there, though. The probability that Z,
I'm running out of space.
is greater than,
Oh.
right, smaller,
No.
negative 1.19. So if you shaded that first, where Z is greater than negative 1.19. So I think the graphs make it very clear what numbers to put in. Yep. Negative 1.19 is back here. Greater than means shade this way. Your second z-score would be this 10 to the 10th where the shaded region goes out to. Sounds about right. Should be big. So left is negative 1.19 and 10 to the 10th. I think that's about the last kind they give you, right there.
As soon as I think I got it, you hit me with something like that.
Mm-hmm.
No, it's just the .85 and the 1.0.
It's just between them. It's greater than the .85, but smaller than that. So those are your edges right there. This one's almost easier than the other two.
It is easier than.
It is easier than the other two.
Yeah, I never.
Because you don't have to remember to.
Yep.
to 10.
You don't really need the graph here. .85,
Well, it's not, but we got you.
1.06, and I'm looking for being in between.
Can we just test that now?
0.05.
We're having a quiz Friday on it.
Oh my god.
.05. What'd you say?
3-1.
3.1.
What was the answer to B?
The fact that I'm answering.
.8830.
Okay, so you're good with that NCDF business. The other thing we have to be able to do is, if I give you an area, can you come back with the z-scores? And I'm going to show you how to do that on the calculator. Did that. Did that.
You don't need to know all the answer to that, do
Okay, and there's 3 of these to do. Can I get rid of this?
we? No.
I forgot it's right now.
How long is it gonna be?
I don't know.
I'm just gonna put the page there.
Onward, Mr. Orton.
Okay, onward. Okay. So that's how you find areas in probability in CDF. Now you're going to use, get rid of that, get rid of that, get rid of that. That was all calc stuff there. Oh, I ran out of paper.
Well, looks like we never noticed that.
No, I've got graph paper. I just don't like using it.
Wait, Schwartz.
What? Let's see what I got for scraps in here.
Here you go.
There's got to be something back here I can use.
I
Nope.
have one old assignment.
One old assignment, okay. There we go, look at that.
So helpful.
So helpful. Here we go. Alright, so find a z-score. 2. Find a z-score. If the area is known. You're going to go under that distribution. And you're going to look for inv norm. And what you have to feed inv norm is you have to feed it the total area to the left of the z-score you're looking for. So total area to the left of wanted z-score.
So would that just be the area they give you?
Well, not necessarily. The first one it is, the second two it's not going to be. There's 3 things they can tell you. We're going to go through each one of them right now. Are you ready? Okay. What number are we on? 3. Find the z-score. That's the area to the left of some z-score that I don't know is 0.6413. I'm going to sketch the graph just so I can see it.
Oh, is it the same, like, it's gonna always be the 0 and 1 for the...
Yep. So, is my z-score I'm looking for, is it going to be positive or negative, and how do I know?
This would be negative.
Think about it. I have 64% of the graph behind me.
The answer's positive.
Yeah, it's going to be positive. I am up here somewhere, because half the graph is below, yep, 50% there. If I've got 64% behind me, that means I'm a little further over this. So I'm over here somewhere. I don't know this z-score, but I do know that the area behind me is 0.6413. So, I'm going to use inv norm to get this z-score. And all I need to know is my total area to the left. Do I know the total area to the left? Yes, because that's what they gave me. So I use inv norm of 0.6413. This will give me the z-score. That cuts that off.
0.3619.
And z-scores usually go out 2 places, just like the table, out to the hundredths place. So we're going to do that here. 0.36.
19.
She just had 2
Just like the table gives z-scores. Areas go out 4, z-scores go out 2, just in tradition. Everybody find their inv norm?
No,
Look for it now.
It's right below.
It's right below the one we were just using.
I didn't even get it yet.
Oh.
Okay.
0.6413.
Shut up.
This is a z-score. That's what's hard about this. Well, you know the buttons and it's throwing out numbers. What are they? So it's just barely above the mean. 0.36 is the z-score. Not even a half of standard deviation above the mean. Okay?
Oh, I have a question.
Yes.
Did it just happen to come out to 1?
Did it just happen to what?
Come out to 1, or is that always gonna...
No, that's just a coincidence there.
Okay.
You're saying if I add these 2 together. Yeah, that's a coincidence. Okay, area to the right of a z-score is 0.8526.
Subtract it from 1.
Okay, if I shade this in, what this is saying is the area to my right is 85% of the graph. So that means I'm over here in negative land. You agree with that? I don't know this z-score, but I know the area to the right is 0.8526. If I want this z-score, though, what do I feed inv norm?
.1474.
Where's that coming from?
I subtracted it from .8.
Yes, inv norm always wants to be fed the area to the left. If they don't give me the area to the left, you've got to find it. So if we go 1 minus, and I think you could even just type that in the inv norm.
I was gonna ask if you could type that in.
I think you can. You don't even have to figure it out. You can type in 1 minus .8526. I think it does not have a problem.
Mine says negative 1.05.
Let's see.
I got two.
Mine doesn't.
Yep, it should be a negative z-score. We're in negative land. Negative 1.05?
Negative 1.07.
07? Who's correct?
Me?
Mine says negative 1.047.
Yeah,
Let's
that's
see.
mine too.
So 05 then.
You're on.
Mine says, okay.
Check.
1.474.
.8526. Yep, negative 1.05. So a little over 1 standard deviation below the mean. Did you type something wrong?
Yeah, I think so.
Yeah. Are we good there? That's so they can give you the area to the left, they can give you the area to the right, and there's one more thing they can do. The area between
Yeah.
a positive and negative z-score is, let's go .6381. So what it's telling me is that these two z-scores are symmetrical. One's positive, one's negative. Same distance away from the mean. So it's centered. So here's my 0. Symmetrical z-scores, negative z to positive z. And I know the area between these two is .6381. This one takes a little bit of work. Yeah, you knew we couldn't have the whole day be super easy. Okay, so if I want to find, once I find one of the z-scores, the other one's just the opposite. So if I find the positive one, then the other one's just the negative. If I find the negative one, then this one's just the opposite, positive. So I'm going to use inv norm. Let's just say I wanted to find this negative one. What do I feed inv norm?
What?
Negative.
Oh, wait,
Oh,
just
wait.
divide that in half. No.
I need to know the area to the left, correct? I need to know this area. Do I know this area yet?
No, you do not.
Not yet. Can I figure this area out? How do I find that area there?
Oh wait, I got it.
What do you got?
Subtract or do 1 minus .6381 and then get that answer and then divide it by 2.
She's correct. Does that make sense to everybody?
I don't follow that. I don't follow. I get it.
Yep. She said do 1. Remember the whole area is 1. Subtract off this middle part, .6381. So there's 36% of the graph left for these two tail pieces.
Oh, and then divide that in half.
And then divide that by 2.
Okay, okay. Alright.
So each one of these is .18095.
Is it
Point
always gonna
one
be like this?
8. There's no easier way to do this one.
Well, because I don't understand this.
Well, I can go through it again.
Well, okay.
Okay. I think it's not that bad
Well,
once
no,
you see it.
I don't have to understand it, I just want to get the answers.
Okay, well then I'll tell you the process. You ready for the process?
Yep.
Okay. You do, when you've got the in-between, you do 1 minus that area, .6381, and divide by 2. Okay, and that gives me .18095. Now I'm going to do inv norm of that .18095. And I get a negative .91 z-score.
And then, in front of that, can you just put plus or minus?
Yep, and then that said, what are, between what two? Between negative .91 and positive .91. That's as hard as it gets. Let me do one story problem and then I'll be done for the day. I know, story problems.
I have 5 lines left.
We can do it. Oh, I don't actually think I'm gonna do it. I lied. I'm not gonna do it. I'm gonna quit.
Yeah.
Yeah, I think so. I'm gonna quit. So, let's see what I can entertain you with now. Okay, let's go with page 210. This is going to feel a little repetitive, but it'll be good. You're going to find z-scores first. Let's go 13 to 16. And then the probabilities. Let's go 37 to 52.
Whoa.
They're all just calculator
Can I
lines,
get
though. No. That'll be good for you.
No.
You'll be getting, I think by the repetition, you're not even going to have to draw the graphs afterwards.
You are?
I don't think you will after you do enough of those.
Wait, are we supposed to draw the graphs though?
I recommend it, but I don't mark them wrong if you don't.
No.
Definitely not doing it then.
So.